welcome everyone. I know that it is difficult to come for the first session, so thanks again, and I will try to share hopefully interesting experience regarding to digital twins. And I suppose that most of you already have at least some information about what is digital twins, but we will have in this presentation actually some short intro about the concept. After that, we will go deeper into Azure Digital Twins service and what is difference between Azure Digital Twins and, for example, some other representations of this concept. After that, we will talk about also best interesting advantages in the context of business and technical side, and we will have several demos. So the initial idea is to have some overview, and digital twins concept is not new. Digital twins concept is 20 years old, and it started with some proposal about modeling of PLM, product lifecycle management. The idea is that digital twins in general can represent physical and virtual systems and to be very helpful for, from one side, creation of mixed reality, creation of interaction layer between original systems and different service for analysis, common data model where we can see the state, and it is applied in almost all areas which we can have in life. So digital twins started with implementation for replicas of virtual systems, but after that, step by step, it stayed very popular for different domains, firstly in aerospace, and after that, step by step to other areas. We have several things which is good to know in the context how we work with digital twins. From one side, we can talk about digital twin prototype. Digital twin prototype is actually something which is used for prototyping. That means we create the model, and this model is used for prototyping and creation of the real system, virtual or physical. Digital twin instance is a replica of existing system. Many complex systems, complex machines, expensive vehicles, for example, some machines for construction, some more complex systems have during the whole their life cycle such kind of replica which is used from manufacturers and dealers of these systems to maintain and control the product. Digital twin aggregate is a solution where we have representation of several instances in one model, and we actually have aggregated data there. So it is not exact replica of one system. It is used usually for specific analysis, and we aggregate from many sources information in one replica. You can see different options for implementation of digital twins. Coming back, what exactly is digital twin? Digital twin is a virtual replica, as we already mentioned. It is a technology which can be considered like part of IoT, AI, mixed reality. We often relate digital twins to IoT because Internet of Things is one of technologies where we can really very good implementation this concept. Even probably it's better to say that digital twin is a concept, but implementation can be different. So we actually use different technologies which step on top of this concept. And as you see, we have from one side option to collect information. And collecting information, we can see this information in our digital replica with values from original system, like one very good option to manage the behavior of the replica, and after that to push back some corrections to the original system. So data from sensors can be used in your digital replica. You can actually make some analysis, make some simulations in this replica to see the results, and after that to push back some changes in configuration to the original system to prove the behavior or to fix some possible issues. So it is something which really be applied almost everywhere. But let's have an overview related to several areas where we have really good stories and already long-term usage of this concept. One of the areas is energy sector. Energy models for optimization are used probably already several years, and solutions which are related to monitoring, management, optimization, predictive analysis related to different kind of solutions around digital around energy domain, use such kind of solutions. Another area is construction. In construction, you have very good options to apply digital twins for several reasons. We will see after that. From one side, you can have prototyping, but with the same model. After that, you can have maintenance and monitoring for the whole life cycle of the system. Health care is the next area. Really, we have many options for modeling in the area of health monitoring to consider some solutions around safety, to optimize some approaches in the healthcare actually for different kind of maintenance of sickness. So this is something which you can see also in real world nowadays. Materials testing, it is something which is related to simulation of behavior of different models. It is also very popular. How actually, from the conceptual point, things work? You have solutions, real work, like such kind of machine for construction, for example, and for complex and expensive solutions, you have digital replica, which is used continuously to behave to monitor behavior of the solution, to make predictive maintenance. One of the best areas where you can have added value is related to predictive maintenance, because you can see based on the model what kind of possible issues you can have, which kind of parts you need to repair, to replace, and you can manage this pretty easy and complex. It is good to clarify that digital twin is not AI component. We relate digital twin to many technologies, but in general, digital twin concept allow to have the clue between original systems and different services for analysis without need to have specific additional logic into solutions for example, analysis, which makes these solutions very specific and dependent on the original system. So integration is one of the areas where we can have additional benefits. Also, nowadays, digital twin is used to have monitoring of users' behavior, their preferences. So marketing and sales also very actively started to use solutions on top on digital twin concept to collect information about users' behavior and to try to find new options to expand their market share, to propose features which probably users need to have based on the behavior and similar things. So we can say that digital twins is not something which helps only to people with strong technical background, but it is a solution which can be used from almost all roles in technology sector, including sales, marketing, and support, of course. We talked already about integration. So you can see also Microsoft documentation and presentations that digital twin is mostly related, like taxonomy, part of taxonomy of all types of solutions, to mixed reality. Why? Because we have from one side original system, we have options to mix some virtual solutions with original systems which can be physical or virtual, but it is just part of possible options for integration. My personal explanation is that this is actually the clue between original system and everything else. We have this digital replica which can be implemented in a way to have event flows from this digital replica to some other services, and if something happened, to trigger any possible business logic which you need. Well, what is the difference between simulation and digital twins? And also prototyping. Simulation is a concept where you have a simulation of the solution with some preset data, but actually it is not a concept which allows us to have real monitoring of the solution with the real load, real situation, and everything what we need. So digital twins, a concept can be used also for simulation models, but simulation models created on different concept, on top of different concept in the past, cannot be used for other functionalities where we can have digital twins. Bidirectional communication between original system and digital replica, monitoring, making connection between different service and original system. On another hand, we have different solutions for prototyping. Here is mentioned the concept BIM, building information modeling, because this is the most popular concept, for example, in construction. We have modeling of solutions where we actually have very similar approach to model construction with behavior. It is not just modeling based on the geometry, and it is used for prototyping. There are many systems already existing on top of this, but it is never considered for real-time monitoring and bidirectional communication. So in the future, probably all these solutions will be replaced with new one based on digital twin concept, because it is cheaper, simpler, in general much better to have solution where you actually can use one concept, I can say one approach, to have implementation for prototyping, for simulation, for maintenance and monitoring, bidirectional communication, and option to integrate any kind of analysis related to the original system in a simple way. So this is probably the most important which we need to know, like main features, main idea of digital twin like concept compared to other technologies. Why we need to relate so much digital twins to IoT? Because there we have pretty good match, and it was realized that we can take advantage from digital twins almost from the beginning. Again, this is just one of many options where we can use this concept. IoT in general related to collecting information from some things, making some analysis, controlling and managing of these things, and this is very close to what we can have with the digital replica concept. Usually, we have in IoT many benefits from this concept. From one side, we can have common model of our solution. That means our sensors can be modeled in a way where you can have related virtual objects in our replica, for example, different containers like spaces, rooms, vehicles, whatever, connection between different elements. So you can have a much more realistic model of the whole solution from the world. And you can have in this replica at every moment state which we have in the original solution. So you will be able, based on this, to have several functionalities. From one side, we can have specific rules, specific logic. Usually, we do this using serverless approach, with Azure Functions, but in general, any kind of logic where we have rules and need to change something is related to calling of separate services via HTTP and calls. And we can have, of course, web services for this or less approach, for example, with Azure Functions. So we integrate pretty standard components with the main core functionalities implemented in the digital twin service to be possible to trigger needed logic. It is much more complex to have this triggering from the real system. For example, to trigger some information vehicle and to send it to the backend for specific cases will be more complex, like requirement for the solution design, instead to send some information in the digital replica. And in the digital replica, if we have some logic where to analyze non-predictable behavior and to raise some alarm, to trigger some business logic, it is much more mainstream approach. The complexity will go down, risk will be lower, solution will be cheaper, and probably faster for implementation. So this is one of the main areas for implementation. Usually, digital twins also are tightly related to the concept around software update and device provisioning. Device provisioning is pretty important for big IoT solutions, for initial configuration of the devices and for control and maintenance which devices are trusted and can be registered in our system, and software update is another key functionality. So we can say that digital twin can be a heart of device configuration management system. Additionally, we will see later, digital twin is tightly related to gateway service. In the context of Azure, of course, it is Azure IoT Hub, and you can power digital with digital twins functionalities to empower IoT Hub to make possible to have much more specific functionalities like multi-tenancy, full isolation of different tenants, which you need to manage with IoT Hub, specific permissions, role-based access control, and some other things which you can model relatively easy with digital twins. At the first sight, many people ask why we need digital twin, why we do not implement custom logic, because for most of solutions, of course, it is possible. I already mentioned this. We can trigger specific logic from device to the backend services using custom implementation. Just this approach is much more expensive, much more difficult for support. We need much more code base to support it, and that's the reason to look for some simplified general approach where we can do this in a similar way, and digital twins bring us exactly this. The first implementation in the context of Microsoft Azure components for digital twins concept is related to Azure IoT Hub and so named device twins. Device twin is a simplified implementation of digital twin concept, which is used mainly for device said, we have for our devices configurations, two configurations, um, current configuration and desired configuration, which are described in the JSON format, and we can manage from the backend and device actually different functionalities, software update, device configuration, without need to rely on network connectivity, which is without downtime. You can have downtime, and when device is available, device will send to IoT Hub its state. Backend will actually read this information, will update desired configuration. Device will read desired configuration to try to update itself in a way as backend logic required. We have nowadays also related to IoT Edge model twins for modules which are based on Docker containers into IoT Edge. It is not part of this presentation, but model twins actually implement the same concept, just it is for models. For devices, we have one configuration. For each of models, if we have IoT Edge, we have similar configuration. So we can say that Microsoft IoT stack offers both device twins and model twins, but in general, because things are pretty similar, we usually name it device twins concept. What we have actually in Azure nowadays, we have Azure Digital Twins service, which we will describe a little bit later. And Azure Digital Twins service is one of the services which are very important nowadays in Microsoft Azure stack. It is again not related only to one group of technologies. You can relate it to almost all areas. And we have powerful option for modeling. With spatial intelligence graph, we have this powerful approach to actually do modeling of our real life systems. We have collection of information from devices. We have role-based access control and multi-tenancy, and we have very rich options for integration, as already mentioned for this. So Azure Digital Twins service has absolutely different implementation for device twins and model twins, which we relate to IoT Hub and also Azure IoT Edge. We have separate service which is for multi-purpose, which manage general cases. We can configure it for almost everything, every type of solution, not only IoT, every kind of real life solution can be implemented with this spatial intelligence graph. So we have really accessible for end users software as a service, which represents digital twins concept. And the Azure Digital Twins service is probably the only one which is on lower price compared to other solutions, ready for use, no need to have heavy development, and you can integrate it in almost any solution where you need such kind of concept. The difference between digital twin and device twin is that device twin is really pretty simplified version of digital twin concept, only for IoT, only for configuration of devices. And we have pretty simple design with JSON, digital twin, service use, spatial intelligence graph, and we have really powerful modeling. I already explained concept of device twin with desired configuration and current configuration. Actually, it match very good for gateway services where you have implementation of service assisted cation. So we have absolutely separated devices and a part of the solution which is on-premise and backend services. This increases security and actually it is much easier to manage solutions using this approach. To be fair, there are different platforms powered by digital twins. So for a few minutes, we will have high-level overview. And usually I never do marketing advertisement for any solution in presentations, but really Azure Digital Twins is probably the only one complete for mass usage, for end users solution which you can get on reasonable price. So we have implementations also from AWS, IBM, Predix, GCP, and other vendors. We have some solutions which are very specific for vertical solutions where digital twin implementation is not common purpose. And we have attempts to create something for general purpose with actually how to partial success from other vendors. What I mean, in GCP, you have no digital twins like any kind of service. You have almost no only dedicated to IoT also components, but the concept in GCP is that you can develop your digital twin and your IoT solution with components which are offered, and these components are not focused on these functionalities. So to create digital twins, you need to model it with one service, to model the original system with one service. You need to implement logic where this model can be used for some kind of analysis. You need to have custom logic to trigger alarms, and with few words, you need to have custom solution with just use GCP services. In AWS, there are some implementations. From one side, we have device shadows. Device shadows are mostly like device twins, and main purpose is to manage devices configurations. Just there are small differences in the concept that, for example, some functionalities in Azure IoT are part of the whole IoT hub and some other services, but we cannot say that these functionalities are part of device twins. But in AWS, they have actually some additional functionalities directly in this implementation, like support of MQTT topics, for example, and some other things. So we have almost the same, but with slightly different implementation. About IoT device configuration, it is similar, but if we go to overall solutions and general digital twins concept, we actually have just partial implementation. We have in AWS, AWS IoT Core, where we have really some core components, but we have also need to have implementation, because for modeling is used one separate service, usually Amazon Marian. They have for analysis also option for different services, for example Amazon SageMaker. You need to integrate more services and to have more additional work, so you have not so complete, not so ready for use out of the box solution, but with additional development you can actually build something like digital twin service also with AWS. If we compare device and device shadows, as I already explained, they are quite competitive like technologies. We also relate pretty often digital twins to Industry 4 and 4.1 because we have, based on digital, one of the main areas much empowered about industrial automation and in general digital transformation for the modern industry. Digital twin service firstly was implemented in 2018, and this preview is different from the second one, which actually stayed at November last year, the first general available edition of Azure Digital Twin Service. So we will just mention a few things for the first preview from 2018, and we'll go to the next one, which is actually also equal with the current release. The most important is that main concept for Azure Digital Twins service was published in this time 2018, 3 years ago, and this was the first time when Microsoft, and not only Microsoft, we were able to see general out-of-the-box service which can be used for representation without additional of digital twins concept. Options for modeling, we have here integration with Azure Active Directory and some other services, data isolation using multi-tenancy, and there were some not disadvantages, but not so mature areas like approach. The first preview, IoT Hub, was in the core of the Azure Digital Twins, which from one side is easy, from another side it actually makes this relation one not very useful, because we can have one-to-many relations. We can have much more flexible implementation if IoT Hub is separate, like service which you know, and we have easy options to integrate digital twin service and IoT Hub. So In the beginning, it was part of IoT Hub. We again use it in tight integration with IoT Hub. So in the modern IoT solutions, we can say that one of the parts where digital twin service stay is still behind the or beside the gateway service, but already like absolutely separate service. Additionally, we have business integration options with twin service. I already shared that. You can write any logic here, and it is based on event flows, which we will see a few minutes later. You can have common data model, and you can have different simulations. The second preview, which were actually absolutely 100% functional, equal with the release which we have, extended some functionalities. We had already flexible modeling and topology. In the first version, we had some preset objects and we were able to extend it in the model. Now we have language for modeling. DTDL, we will talk a little bit later about this, and we can describe with this language almost everything. We have not only in preview, and it's also some default limitations for some metrics, which actually are adjustable. That means if you reach some limitation, you can ask Microsoft support to increase this limit to reach what you need. We have in the current release also very good integration with calling any HTTP endpoints. Mostly you can see it in the documentation, like integration with Azure functions, but it could be with any web service. And we have, of course, very good integration with tools for performance monitoring and analysis, which we can use. We have one general flow now, one general concept, sorry, for all models because of the general language. We have general concept with Intune with other services. We have several options for input and output without need to have implementation with HTTP end calls, and for all other cases we need to have this general approach. We have also Azure Digital Twins Explorer. It is open source solution built on top of React web application, which you can download, you can deploy, and you can build quite complex models with this tool for free. Additionally, companies like Bentley, for example, and ANSYS offer pretty powerful tools for modeling, which are out of the box integrated with their engines for finite element modeling. So you can use third-party solutions which are built with integration with in partnership with Microsoft. In IoT, we can have different types of design of our solutions. We can have in all areas which we already discussed around gateway a service around common data model, configuration about analysis and integration with other services. Azure Digital Twins concept. We have general flows, and we will see actually how it works now on the several demos. Before to switch to demos, because we have not much time, just several more things. We can ingress data via several services out of the box, like IoT Hub, for example, Logic Apps, and any service, I mean web service, of course. Logic Apps can be used because implementation with HTTP and calls is actually very well supported, so we can have a rising of some logic in your solution, also without coding, and integration with Azure Digital Twins is relatively easy. You can use also Event Hub, Event Grid, Service Bus in pretty straightforward way. We have a common approach how to collect events and how exactly event flow is going, and in the end of these different flows we have event dispatch where we can call different services to trigger specific logic. And you can have situations where, for example, we are getting some data from another service, for example, with Azure Function. Again, here can be any service. Using HTTP call, we can change the Azure Digital Twins API some component into some component in our model. This can affect triggering of specific logic, which will after that call another services, and we can make some corrections. The most popular approach. And to have common flow, usually we have event grid, for example, which collects different events, and based on whatever is expected, he's sending these events to different services. So this is actually the main approach. In DTDL, this language for modeling, you have options again with Akka JSON syntax to implement design of our models. So this is the most important implementation of Azure Digital Twins concept. Stay more and more popular for common data model for IoT solutions. This is some kind of high-level design of real-life solutions which we are developing. Possible to have samples, for example, for predictive analytics, where we have digital twin service. We are calling this information in the following flow. We integrate this digital twin service with, for example, Event Hub. The Event Hub specific application is getting information and send it to anomaly detector service, for example, which is part of Azure Cognitive Services, and we can have in such kind of approach pretty fast implement where we can find some anomalies and trigger additional logic. This is the most important, just overview of the old model, first implementation, we had, as I mentioned, several spaces, and we needed to extend this model. And nowadays, we can have everything from the scratch, so you have no need to rely to specific preset models. We will not go into details because of limitation of our time. I will try now to have some demos. For demos, I will share my screen from my machine and we'll try to show you information how to build digital twins solution. So let's try to share other information. I'm in the past when we had also it was possible to have both old preview and the new and current. This new is the current implementation, but nowadays you have only one option. As you see, there are no specific tags for this. You need to have some main options, pretty common for any service. For example, Azure Digital Twins 3. There are several specific things you need to have owner role. If we do it this way, we need to assign a role. Now, the role of owner should be user, which is created in the current Azure tenant. So it is something which is not allowed for guest users and personal accounts. You can make this service with public endpoint by default, with private also. You can use managed identity, and you can build this configuration pretty fast with review and create. I will keep this running and will show you what is already implemented, because we have several instances already. So we have one instance here prepared for our demos. We have in this instance several things. Yes, the new instance is ready, but we have already prepared this into the access control. You have actually different types of roles which you can assign. Here you see that you have Azure Digital Twins data owner and data reader. To access data and to change data, you need to assign to the users these specific roles. And you have actually in Active Directory, let's go to Active Directory, in Register Applications, Here you have different applications which are used, for example, like this one, for access to your digital twin service. So it need to be done. You need to create digital twin service, and you need to configure it in a specific way. Now I will just try relatively fast to demonstrate at least one demo. We have one device simulator which simulates temperature sensors. It is created already to save time, so I will just run it. It is connected to IoT Hub, so you have no need here to have some specific credentials. And now I will show one additional application, which is actually sample client. You see that you need to connect it with tenant ID, client ID, and endpoint of the instance. And now I will be asked for credentials. Of course, in the real life, you will have such kind of applications hosted in Azure. Authentication requires additional screen. I need to have now additional screen where to say, okay, for example, this is my user. Let's try to make it again. If everything is fine, I need to continue. Yes, in general, the next call after approval for some reasons is blocked here in my office, but you actually can have such kind of client created, and we can now see for the sensor which from the sensor which is observed, what we have like temperature. So this program reads from our digital twin system what exactly we have, and you can trigger additional logic. We have many samples which I will share later with organizers of the event, so you will have all this information and you will be able to try this service and to play with samples. Because we have not much time, we need to stop now. Thank you very much for attendance, and if you have any questions, I will be glad to answer your questions. feel free to contact me later if you have additional questions in the Q&A sessions or at the post-event communication. You can receive from organizers probably my contacts. I can also answer you at LinkedIn and other social networks. So if you are interested in digital twins, I will be glad to discuss with you technology and to help if you have any need. I think that this is the most important for now. So thanks again. And if later you consider any additional questions, feel free to contact me. If not, thanks again and hope to see you soon.